Good morning, everyone. Myself, Ms.Priyadharsini, working as Assistant Professor in the Triple Department of R&D Engineering College. Today, I am going to discuss a topic on series and parallel combination of the resistor from the subject Principles of Electrical Engineering. So, first you will see the resistance. Resistance, if they are connected in series. So, we know a resistance, the property of the resistance is to oppose the flow of charges, and there are two different connections are there. One is a series, another one is a parallel connection. The resistance are connected in series. For example, this is R1 and R2. The two resistance are connected in series. R equivalent is R1 plus R2. So R1 plus R2. If they are connected in parallel, if the two resistance are connected in parallel, the current is going to get divided, and R equivalent is 1 by R1 plus 1 by R2. So R1 into R2 by R1 plus R2. Okay. The next is voltage division rule. If the two resistors are connected in series, so what are the factors next is going to come is the same current will be flowing, but the voltage will be getting divided. So V1 is the voltage across the resistance R1 and V2 is the voltage across the resistance R2. V1 is equal to V into R1 by R1 plus R2 and V2 is equal to V into R2 by R1 plus R2. So always, if I am calculating V1 is equal to V into that corresponding resistance by R1 plus R2, and here V into R2. That is for what resistance we are going to find out. That corresponding resistance value has to be come in the numerator. That equivalent will be coming in the denominator. So voltage across one of the resistance is equal to total voltage across the series combination into that value of the resistance by sum of the individual resistance. The next is what is the voltage across the 10 volt resistor? The voltage across 10 ohms resistor is if the circuit is connected like this, the 5 ohms and 10 ohms are connected in parallel, and the 50 volt is like this. V 10 volt. The voltage across the 10 ohms resistor is 50 into that same resistance. So for what I am going to find out for 10 ohms, so 10 ohms by the combination of 10 plus 5, it is 15. So answer is 33.33 volts. The next is current division rule. The current is how they are getting divided. In the parallel circuit, the current will be getting divided. Is the total current. It is divided into two branch currents, I1 and I2. If I want to find out I1, I1 is equal to I into R2 by R1 plus R2. That is opposite resistance we have to consider. And I2 is equal to I into R1 by R1 plus R2. This R1 resistance I have to consider. That is opposite resistance we have to consider. So total current drawn by parallel combination into value of the opposite resistance by sum of the individual resistance. So determine the current through each resistor. So this is the problem they are given. They are asking us to find out what is the current flowing through each resistor, I1, I2 and I3. So for example, I1 is equal to the total current which is flowing through the resistor is 12 ohms. That is from the supply. If I want to find out the I1, I should use the opposite resistor. But in the opposite, I am having two resistors. They are connected in parallel. So first, I have to find out the R equivalent of these two things, and I have to substitute that. So what is the R equivalent of 4 ohms and 4 ohms? The total is going to be the 2 ohms. Then I have to substitute 2 by 2 plus 4. Answer is 4 ohm, 4 amps. So I1, what is the current flowing through? That is I1 is 4 amps. Find the current and the voltages in each branch. Okay. So totally there are resistors of having 5 ohms resistor, 10 ohms and 12 ohms resistors are this. They are asking us to find out the voltage drop across each resistor. So if I want to find out the voltage drop across the each resistor is equal to that is voltage drop means V is equal to I into R, and I have to find out the current flowing through the 5 ohms resistor. Okay. So here they have given the total current flowing through the circuit is 5 amps. So 5 into 5, it is 25 volt. And similarly, this 5 amps is getting divided by, that is we have to use the current division rule. Then only we can able to get V1 and V2. So if I apply the current division rule, I will be getting V1 and V2. And then I can apply that Ohm's law to find out the voltage drop across the resistor 10 ohms and 12 ohms. So here by using the Ohm's law, find phi is 25 volt and I is equal to total current into opposite resistance by summation of the two resistance. Is equal to 12 by 10 plus 12. So 12 by 10 plus 12 is 22. So if I am substituting with the 22, answer is 2.7273 amps. If this is multiplied with this 10, the answer is 27.273 volt. The next is find the equivalent resistance across the source. So we have to find out all the resistance which is connected across the source. So here it is easy. So first we have to see what are the different combinations are there. They are connected in series and parallel. This 82 ohms and 18 ohms, they are connected in series, and these two things are connected in parallel. So first you find out the R equivalent of this, and then you add both the things, and similarly you add both the things, and then you find the R equivalent of this combination, and that has to be added with 100 ohms to get the R equivalent. The next is find the equivalent resistance across the source. So 2 ohms and 4 ohms. And here first we have to see whether they are connected in series or in the parallel combination. So this can be solved in the two methods. One is equivalent resistance method. Another one is the star and delta conversion method. So if this source is connected here, always you have to start the method from the opposite point. So here 2 ohms and 2 ohms, and here 2 ohms and 1 ohm. So 2 plus 2 is going to be the 4, and 2 plus 1 is equal to 3, and they can be connected in parallel. So parallel means then they have to be simplified. For example, this is my 4 ohms and this is the 3 ohms. If they are simplified, this is 1.2, and 4 and 4, if they are equivalent, and similarly I will be getting 4 ohms. Okay, and then again we have to simplify this 2 ohms. This 2 and 1.2 will be connected in series. So 2 plus 1.2 is 3.2, and 3.2 and 2 is they are connected in parallel. Once again we have to find out the parallel for that, and finally the answer is going to be 1.05 ohms. And if I use the Ohm's law, 30 divided by 1.05 ohms, I will be getting the current, that is the total current which is flowing in the circuit. The next is going to be the Kirchhoff laws, and Kirchhoff laws, there are two laws there totally, KVL and KCL, and Kirchhoff voltage law and Kirchhoff's current law. What is Kirchhoff voltage law? The Kirchhoff's voltage law states that algebraic sum of the voltages in a closed path is equal to 0. V1 plus V2 plus V3 is equal to V. V is equal to V1 plus V2 plus V3. Sum of the voltage rise is equal to sum of the voltage drop, and Vs is equal to V1 plus V2 plus V3, and the drops can be I into R1 plus I into R2 plus I into R3. And here the three resistors are connected in series, and what is the total current it has been flowing? R1 plus R2 plus R3. V by R1 plus R2 plus R3 is equal to I, and if I am multiplying this I into R1, the corresponding values are V1 plus V2 plus V3. From the source, positive terminal, the current is leaving, and in this element, the current is entering towards the node. For the circuit shown, determine the unknown voltage drop V1. So we have to find out what is the voltage drop V1. So this is going to be the voltage rise, and the remaining things I can take it as a drop. If the voltage rise is equal to voltage drop, the remaining pending is V1. So from this, if I substitute, V1 is equal to 19 volt. So 30 is equal to 2 plus 1 plus V1 plus 5 plus 3. So totally the answer is 11. And V1 is equal to 30 minus 11 is 19 volt. The next is we are going to use the mesh analysis. The KVL will be used is used in the mesh analysis. So here they have asked the question: determine the mesh current I1 in the circuit shown. So it is a 3-loop path, and they have mentioned the currents as I1, I2, and I3. So for this circuit, I am going to use the KVL rule. So KVL is voltage rises, voltage drop. If I am applying that, we have to use the KVL rule. So first is number of meshes is equal to the number of equations. So totally there are 3 meshes are there, and you will be getting the 3 equations for the solving. And here first I am considering the first path, and 50 volt and 10 ohms, 5 ohms and 3 ohms. So how many currents are flowing in this path? So in this path is I1, but this 5 ohms is shared between the I1 and I2, and this 3 ohms is shared between I1 and I3. And see the direction. If the directions are in opposite, is I1 minus I3, and here the direction or in here also the direction is going to be the opposite. I1, same direction, so I1 plus I2. So 50 is equal to 10 I1 plus 5 I1 plus I2 and 3 I1 minus I3. and then apply the KVL rule in the loop 1, and I am getting the equation as 18I1 plus 5I2 minus 3I3. And similarly in the loop 2, the same rule has been applied, and the answer is 5I1 plus 8I2 plus I3. And finally the KVL has been applied in the mesh 3, and answer is this. So if we are applying the Cramer's rule, and after that finding the del is going to be the value of 356. So from this, what is I1 is 3.3 amps. So I1, I2 is minus 0.997, and I3 is 1.47 amps. So the application of the KVL is, especially we are using in analyzing the mesh to find out the current I1, I2 and I3. And similarly, in the next circuit, determine the current in the bridge circuit by using the mesh analysis. So totally, how many paths are available? So 3 paths are available. So I1 plus I2 plus I3. So here, if I am applying this rule, and 10 is equal to 3I1 minus I2 minus I3. And here, if I am applying the KVL to the loop 2, this is the second equation, and KVL to the loop 3, and this is the third equation. If I am finding out applying the Cramer's rule, the answer is I1, I2 and I3. So what is my I1 is 7.5 amps, and I2 is 6.25 amps, and I3 is 6.25 amps. So in this video, we saw how the resistors are connected in series and parallel, KVL and KCL rule, how the KVL has been used in the mesh analysis. So thank you.